right, let's take a look at section 5.6 and see if we can just look through the problems that you have to do, which is page 455 to 457, 1 through 10, and see if I can at least help you set most of these up. Let's take a look at number 1. It says in 2006, the world population was 6.5 billion. The exponential growth rate was 1.14 per year. A, find the exponential growth function. All right, exponential growth functions have the form P of t. This is for population growth, but they all follow the same type of um, pattern. And this particular problem has to do with population. But if you look back earlier in the section, you start with P naught, which is your initial population, times E, because it's growing continuously, to the KT, where K is your exponential growth rate, and it's going to be greater than 0 because it's going to be a growth, and T is the time in years. So the exponential growth function in problem number 1, you're going to need to fill in two things. You need to fill in your initial, and you're going to need to figure out your rate. Everything else you leave. You leave an E, you leave a T. You do need to write the exponential growth rate as a decimal. So if they tell you that you've got a 2% growth rate, you wouldn't write a 2 for K, you would write 0.02. So look at what they tell you the growth rate is and write that in. Question part B, estimate the population of the world in 2009 and in 2015. Now, for 2009, you're not going to use 9. We're talking about years since 2006. So for 2009, for T, you would use 3. In 2015, for T, you would use 9. It's 9 years since this function started. When will the population be 8 billion? What you would do is you're going to put 8 over here. Now, because you're going to put your initial, you don't have to put, if it's 6.5 billion, you don't have to put 6 and then 5 and all the zeros. You can just put 6.5 and know that your answer is going to be in billions. So I can put 8 here, write the rest of my function over here, and then solve for T. You're going to have to do natural logs to solve this problem. And then D, find the doubling time. Find the doubling time. To find the doubling time, you just have to do, the equation is that it's the natural log of 2 divided by your K, and that'll give you your doubling time. Natural log of 2 divided by K, and that'll give you as a decimal. K has to be written as a decimal. All right, that's a little bit of hint on number 1. I'm not going to get through all 10 of these, I don't think. Number 2, we're talking about rabbits, and the way that their population grows. Looks like about the exact same problem. The only thing I'll caution you here is that in this case, T is going to be days. They grow at a rate of 11.7% per day, which would be 0.117 if you're going to do the K value. I'll give you that. When they say graph the function, just graph it on your calculator and take a look at it. What will the population be after 7 days? So you plug in 7 for T. Then it asks after 2 weeks. So you don't want to plug in 2. You want to plug in, since this is the number of days, figure out how many weeks are in 2, how many days are in 2 weeks, and then find the doubling time, which is, again, the natural log of 2 divided by your rate. All right, problem 3 is going to be filling in a chart. They're going to give you some different things and ask for what the growth rate is or what the doubling time is for different countries and their population. It's either the natural log of 2 divided by the rate will give you the doubling time, or the great thing about solving functions for different variables, which we have done, is that you could switch the K and the T, and if you were looking for the rate, take the natural log of 2 divided by T, and that would give you the rate. It's going to give it to you as a decimal, so you would need to switch that over to a certain percent for the year. And that's how you do number 3. All right, for problem number 4, they're going to give us our initial amount. They're going to tell us that in 1998, there was 500,000 DVDs produced. And then in 2006, which would be 8 years later, there were 29.01 million. And these are both in millions. And they want us to find the value of K. Well, here's what you want to do. In 2006, there was 29.01 million. We started with 500,000, and that was after 8 years. So up here in this exponent, I'm going to put equals 8K. So then I'm just going to need to solve for k. So divide both sides by a half, and then you'll natural log both sides, and its rules and properties from section 5.5. Um, and see if you can figure out the value of k. Once you know that value of k, you can rewrite the equation. The amount will equal, you'll do 0.5 e to the, now you'll know k, whatever it is, times the time. And they want to know for like 2005, 2008, and 2011. So your time will be your years since 98. So for 2005, you would use 7. For 2008, t would equal 10. And for 2011, that would be what, 13 years? And so that's what you're going to plug in once you know what k is. Problem number 5, population growth of Israel. They give you the growth rate, and they tell you the population in 2005 and the land area. And what they want to know is how long will it take for there to be one person for every square yard of land. So they give you the square yards. So problem 5. Whoops, I'm running out of space here. They give you the land area. It's a big number. Good thing you're not having to do this without a calculator. They give you the initial amount. So 6276883. They give you the rate, which is 1.3% per year, so 0.013 times t, and you've got to solve for t. So you divide both sides by the 6 million, and then you take the natural log of both sides and pull this exponent to the front. And that should be pretty, in fact, let me go ahead and do this one with you. Divide both sides, and number 4 that I just went over is done a lot like this same process. So I'm going to divide both sides by 6,276,883. So let's see if I can get these numbers entered in here correctly. 24,839,654,000 divided by the population, 6,276,883. So when I divide that, I get 3,957.3. So over here, dividing these is 3,957.3 equals, now these canceled out, and I get e to the 0.013 t. Natural log both sides. So now I want to do the natural log of that 3,957. And I'm just going to put natural log of, instead of retyping it, I'm going to put the answer. You'll get roughly the same thing if you type in 3,957.32. I'm trying not to round too much. So 8.28 is what I get. So I get 8.28 for this side equals, now I'm going to take this and pull it down to the front. So 0.013t times the natural log of e, which is 1. So 0.013t equals 8.28. Divide by 0.013. And I get, for my answer, divided by 0.013. And again, yours may be slightly different based on how many decimal points you rounded to, but I get about 637 years. So t equals, in about 637 years, the population of Israel will be such that there will be 1 square yard of land for every person in the country. All right, problem number 6 is going to be done the same way. Same thing for 7 and for 8. They ask about the doubling time, which goes back to a lot like problem number 3. The only thing that's different is that after you find that, they want you to plug in for 5 years and find that value. And I think for 9 and 10, the only thing that's different is for 9 and 10. Number 9 is carbon dating. So let me go over. All right, for problem number 9, I accidentally wrote this wrong. They tell me that this particular mummy has lost 46% of its carbon-14. Now the decay rate for carbon-14 is negative, that's hard to read, 0.00012. So if it's lost 46%, then 54% remains. What I want is how much remains. So 54% remains. My function is e to the negative 0.00012. So to solve that for t, I would natural log both sides, bring that to the front like we did on the last one. And natural log of e is 1, so then you just have to find the natural log of 54 and divide by this decimal that's the decay rate, and that'll give you the number of years that that mummy has been in the tomb. Um, Same thing for number 10. It's based on carbon 14, so you're again going to be using this decimal. If I expect you to know that on the test, I will give you that decimal amount. All right, good luck.